to take a minute here to introduce our next speaker just for a moment. Michael Gough is going to be talking to us about memory forensics. So before we get deep into the content here, I just wanted to say, like, this is how we form our summits. We've got two different styles of talks. Our keynotes that we have are very high level, very aspirational, very strategic in thought. Absolutely critical for us to know where are we going as a community. And a lot of our other talks are going to have some of that as well, but we also now pivot hard right into very deep down technical information. And Michael's going to be sharing with us some of that. Michael comes to us with a very extensive background in incident response and consulting. He's currently with the NCC group in actually Austin, Texas. So along with two of our other speakers that will be coming up later in the agenda, I think Michael's one of the few folks that actually showed up for the live event, so to speak. So he's coming to us from the original source of the DFIR Summit, but we're glad to have his support here. He also brings to us a lot of experience, as I said, in the incident response realm. So you're going to see some of our talks center more heavily on the digital forensics, some more heavily on the incident response. This is going to kind of be a bridge between them both, so it's exciting to kind of kick off with that. So with that all being said, we are just about at the kickoff time for that. Talk about how to find things that are hidden by using memory analysis, because as I know Michael is going to talk about here, sometimes it can be easy to hide from system artifacts like the disk, but memory is going to, in many cases, be your ultimate source of truth. So, without any further delay, I'd like to go ahead and bring Michael into the broadcast, if you will. Thanks for joining us, and I will turn it over to you.
Thanks, Phil. Good virtually seeing you, because I'm down here at the Hilton. There's nobody here. What's going on?
Well, please enjoy a beverage in the lobby bar when you're done for me.
I will. All right. So what I'm going to talk about today is the need for us to check or create a running process. So process, so you differentiate processes from a process. Shout out to Andrew Hay, because I'm going to use the Canadian version of process to differentiate the two. So we are all professionals. We need a process to find and look for these running processes. I am a blue team defender ninja, malware archaeologist, logaholic, principal incident response engineer for NCC Group. And I love properly configured logs. Many of you probably heard me do talks on logging, because they tell us who, what, where, when, and hopefully how something occurred. I am the creator of these cheat sheets. As Phil mentioned, I have a long list of things I've done for the community, and within it, I'm also the co-creator of LogMD, as well as the co-host of the Incident Response podcast. So why this talk? Fileless memory, or fileless in-memory only malware, right? To expand this expanding threat that's becoming more and more common, too common actually. The idea here is commodity malware, red team engagements, and of course APT attackers use it. This method can avoid many security tools. So let's rethink or redefine fileless malware. We did a podcast recently on this subject, and it troubles me when we hear the generic term fileless malware, because I think as you listen to the definitions I'm about to talk about, you'll immediately know where to take your mind and how you might go about looking for these various fileless malwares. So rethinking it, fileless malware that can only be found in memory, right, of a running system, malware plus memory equals Memware. So if I say to any of you, hey, we got to go look for some Memware, I think as incident responders and forensics people, we can wrap our heads around, we got an in-memory scenario. No files can be found if you scan the disk, as Phil mentioned, and the system, while the system's running anyway, or very short-lived, right? They download the file, they execute the file, they delete the file. A lot of this is also bypasses your file integrity monitoring solutions. And the typical infection vectors are injection, DLL sideloading, hijacking, process hollowing, download source code, and compile on the fly, .NET, JSC, etc. Also, users can double-click this to start the attack as well. Fileless malware, the file that lives somewhere, right? It has to live somewhere. So let's do a better job guiding people on signs of where to look for it. So let's look at these terms. Regware. Malware plus a payload in the registry is regware, right? It's not fileless. It's just hidden in a different place. WMIware. Malware plus the payload in a WMI database is WMIware. PowerShellware. Malware plus payload in PowerShell equals PowerShellware. Compileware. This is malware plus a payload compile on the fly, can be called compileware. Downloadware. Malware plus payload downloaded each time through text files or whatnot, compiled on the fly, can be known as downloadware or maybe lolbassware. And if you think about this for a second, as I mentioned these, I think we all can kind of say, oh, I have to go look here for that, or I might have to look this way for that. And that's the purpose of looking for very specific fileless malware types, so we can focus at how to find it, how to hunt it. Keep in mind, not all malware will have an auto-run ASAP. If you saw the latest TrickBot recently and saw its MO, they actually infected the workstations and used SMB and then jumped over to the domain controllers and injected the malware on the domain controllers. And nothing was running or nothing was found on the box itself except in memory. So this is a great tactic to go and detect it, as systems will look, analysts and security systems will look on obvious indicators. They just won't be there, only in memory. And especially the red team doesn't like to leave IOCs, so they're obviously not going to write auto runs as well, right? They get in, they launch stuff, and they'll live as long as the system doesn't reboot. Or like Drydex showed, auto run is created on shutdown, then deleted on startup once the malware loads, so there's no signs of persistence. Pretty typical for some of these commodity malwares. We saw this with WinNTI, dealing with them in the gaming too. So what is in memory may be all we can see. And like I mentioned, TrickBot on the domain controller doesn't survive a reboot. And so this is something we need to really pay attention to, because now TrickBot's a commodity malware. Lots of us have seen it, lots of us have evaluated it, lots of us have gotten it. And so we now need to think, uh-oh, I can't go run tools and check user directories for things. I can't go look for an ASEP because it's probably not going to exist, right? So we're going back to old school forensics in some aspect of making sure that memory is something we look at, or something that's running is something we look at. So how do we find this stuff? First, everything you should do should be mapped to MIBR attack. If you haven't done this or don't understand the logic of what I'm talking about, it just got a lot better with sub-techniques. For example, the items in memory only, or the types of things I've talked about thus far, are Technique 1500, compile after delivery, Technique 1127, trusted developer utilities, Technique 1055, process injection, Technique 1196, control panel applets, etc. And there's more. And then the sub-techniques that just got released last week break those down even better. And this allows you to target your hunts, target your tools, and try to figure out, can you detect these things? Do you have a way to go about checking these running processes, new control panel applets, signs of injection, misuse of wall bins, and then things that compile on the fly, as just an example. So we need to create a process to start looking for this condition. Tools are just not preventing this technique. I worked with a very large EDR where we were definitely beat up by control panel applets because it was so noisy, there was no alert from them. And so this was the technique that was used, and the red team did very well at it. So we need to build a better process, hourly, weekly, monthly, build some routines to detect and alert for this type of technique. We need to build a process into our daily, weekly, monthly, yearly routines for threat hunts for this techniques. Fighting Memware. Traditional forensics has us dumping a memory image and running tools like volatility against it. Now, for me, that's very useful in many cases, but it's also not very scalable if I want to try to run this on 100 or 1,000 machines. So I need another way to look at it. But volatility lets me dump the files, lets me dump the DLLs, the drivers, which then I can post-process to see if there's anything going on with them. And we'll show you some of that here in a second. Logs can contain a lot of data. This is going to be a big win here. You can see the CSE compiles. You can see lol bins being executed, right? So logs contain a lot of detail. And you can alert on this behavior if you collect, then detect, or hunt. Checking running processes and their modules on a live system is a great option, because then I'm just scanning what's running currently. It's quick. I can do this across all the machines, lower impact, a lot more speed involved here. And better yet, look for signs of injection would be awesome, because that's where these guys are side loading, injecting into Explorer and other processes. Look for other artifacts: autoruns, ASAP registry keys storing scripts or large payloads, WMI databases storing scripts and or payloads, and odd PowerShell, large blocks, obfuscation, base64, etc. These things definitely, these in-memory components will often write to that. Gough stored its payloads in the registry, so did WinNTI. So looking and eliminating that is a big win there too. So here's some examples. I've got Gough, Quackbot, and Dridex. In Gough's case, they did an implant to syswile64 service host. Well, anytime I see syswile64 anything, I'm going to investigate it. And if I see signs of implants like we show here, then definitely it's highly suspect. And here's an example of Quackbot doing a similar technique. So Quackbot is implanting into syswile64 Explorer. These are all 64-bit machines. Microsoft doesn't really support 32-bit much anymore. And so it's real obvious to me that something fishy is here when I see 2 Explorers and one of them's in syswile64. And then looking at Dridex, it's a little different. Dridex sideloads a DLL using a trusted known good binary in an odd location, and that's really the trick there. It definitely injects into the parent, which in this case is run DLL32, how they launched the DLL in this case. The item, obviously the DLL is not signed, it's not from the catalog, so these are dead giveaways to us in the logmd area when we do a static analysis with our v9 module, and that the file is definitely malicious, no matter what they name the file. I made it named Dridex just for ease of being able to read it. In the case of extracted files, so things we extract or dump with logmd, or we would do the file extraction with volatility, here's the same kind of scenario. I take the files and I post-proc Quackbot, and I can immediately see through a string query that we do that the PDB string is very odd. It's something that definitely doesn't look normal to me, and it would be suspicious. Here's Gough doing some weird things with their naming. So again, what the external file name is not often what the internal or original file name is. And so those two stick out as artifacts that we can definitely parse the strings for and see, or the metadata. And in Dragdex's case, they use this great PDB location: C stop, soft duck, liquid build, wide, divide, dictionary.pdb. That would stick out to most analysts, I think. And these were evaluated with the logmd v9 module as we extracted these files. So some more examples, right? The bad guys, can call out to the internet, download code, or compile it. They can use the HTTP capability within Excel, for example, right? As just one. They can use all the lol bins to fetch this stuff as well. And they fetch the malware so it doesn't live on disk. They drop it, and then they can do many things, right? Cobalt Strike and Scythe make custom malware packages that you can configure to do whatever it is you want to do. The lol bins are trusted, signed Microsoft binaries that have the ability of loading, like we saw with Dridex and Run DLL32 in the previous slide. RegServe can call out the internet. RedAsm can call out the internet as well. There's a whole list, which I think started out with, I don't know, Casey did a list of, I don't know, 15, 20 lol bins, and it's well over 100 now, and here's a link to the GitHub page for that project. Then there's the compilers. So if I download these .cs and command line files into the temp directory, I launch csc.exe or msbuild or jsc, whatever the combo of files you downloaded, and then I just compile them on the fly and inject them into memory. So watching for these executions are key as well. And then they may write to disk on shutdown or delete on startup, like in the case of Dridex's previous cases and other malware I have seen. So in the course of the compile on the fly, here's an example where you can see the .cs and .command line files on the right, and here's what it looks like in Process Explorer, showing command.exe, calling PowerShell, calling CSC. So the parent-child relationship is definitely odd here, and clearly CSC compiling would make me investigate it. So look for the random.cs, the random name.cs, the random name.cs command line, and executions of CSC, exe, no config, full paths. Control panel applets. I really don't like these, right? These things over here, all the control panels full of them, the Flash player, Java, etc. And they're generally executed with a run DLL32 or control.exe. Whatever directory they want to use, they can use. And they call it whatever it is they want to call it. Fake Java, they make it look like Java, make it look like Flash player. And because they're launching it where their CPLs live, it's highly noisy. And it pretty much can live under the, go under the radar and live there, and nobody will really notice. And many EDRs, one I've had experience with, just doesn't have an alert for this. And it is a MITRE attack technique ID, thus why mapping to MITRE is a great thing. It launches a bad DLL into memory using a lolmin. The CPL files load all the time, so it's very noisy. So you're going to have to really work on excluding all the noisy normal traffic, the baselining of this scenario. Third-party applets are not well signed, unfortunately, furthering the investigation of making it look obvious. Well, the bad stuff will be unsigned. Well, surprise, some of the good stuff will be too. Many EDRs don't learn this method, and red teams love this method. It comes with Cobalt Strike, Scythe, and others. Will utilize and provide modules for you to infect from a red team perspective. So monitoring for and threat hunting. We need to develop a process to monitor and detect for and or threat hunt for signs of these techniques. Step one, you have to enable the data. So if you're doing logging and you need to go back to the cheat sheets I mentioned earlier, configure your system so at least collect this data. In the case of the Windows, it's not on by default. Sorry to say, Microsoft does not do a good job default logging. Mac does a better job. Linux, you're going to have to do some work there as well to make sure that you are collecting this information so that you can look for these signs of these command parameters of compiling and whatnot. And enable, for Windows, be sure to enable and collect process command line. This is crucial. This is, a lot of EDRs do this automatically. And I know there's a FUD of, hey, I may see a password, but trust me, the red team and the bad guys are not looking at logs for passwords. They are doing Mimikatz, they are doing Responder, they're doing keystroke logging to get your passwords, or you're just going to give them up as potentially we saw with the Twitter account hack, or somebody might have been paid. So there's lots of ways to get passwords, and reading the logs is not one of them, especially because they will rotate as local logs are very small normally. Step two, create detections for many of these techniques I've spoken about so far, and process command line is going to be key in seeing these initial execution. It's in the parameters from a log perspective. Step three, come up with a process to scan running processes and their loaded modules. Running processes, as we saw with the injections in the case of Quackbot and Kofter. In the case of Dridex, it's a side-loaded DLL and injection into Explorer. So it's real key here to look at what's running on the box. Again, you can do a volatility memory dump and process it with volatility, or go that route as well. More time-consuming, larger files. But seriously consider looking for a way to scan running processes and the modules that they load to look for signs of these bad food. And to detect these in-memory only infections. This should be both for regular detection and for threat hunting. So I can threat hunt, go out and connect all these machines with something like Arthur, WinRM connections, or any other tool you have, Big Fix or whatnot. Run a tool that looks for this condition, dump it out to a location that's known, and it goes to your SIM, or you just pull back the results and parse it manually. If it's a detection mechanism, again, you can run this as a scheduled task or whatnot and get this sent to your SIM to alert on. And then, of course, you're going to filter out the known goods, and hopefully you'll have a pretty good alert for any signs of injections. There are definitely signs of normal hooking. That's normal. Chrome and Firefox will hook all the time. And so look for the injections and the implants. And again, watch for these indication of injections is the biggest key here. If you want to go the next route after you dump files from, let's say, volatility or LogMD or other item you want to dump files from, you can scan the string output of that file and look for indications of these strings. So here's a short list. And these are normally occurring in other programs for sure, but definitely if you were to evaluate the 3 samples that I showed you, these strings show up a lot. It's a high false positive rate, but it is a good first step of doing some string parsing for injected items. Lulbins, Lulbats that can download stuff. So here's a short list of items that we know can download files. According to Cisco Talos, and I would concur with several of these. I've seen these quite extensively. MSHTA, heavily used by Covter, for example, and WinNTI. These on the right will show a lot more use in the wild as regards to downloading stuff. PowerShell, obviously, Register 32, we see that. BitsAdmin, the background intelligent transfer service, can all download things to your box. And so these are two lists you can use to help craft your alerts, hunts, and or detections. And remember, it's not that these execute, it's the process command line that is key here. It's what executes after the name of this binary. And of course, map these to minor attack. Many of these items are in minor attack as technique IDs or sub-techniques. Best options for process tools. Well, log management is going to be your best friend here, right? If you can send the log data of these executions with their parameters to a log management solution, by far going to be your best option to catch these things as they execute versus worrying about or trying to detect these later. If not, then you will need a process to manually check for running processes and their modules and signs of injections, or you're going to have to do large-scale memory dumps with a tool, enterprise tool like Incase or something, or manually go dump all the memory in machines every so often as part of a hunt, and then process the volatility, etc., and then maybe process that up with LogMD. But you'll have to come up with something. If you don't, you're going to get nailed, like TrickBot has shown with the injection of the domain controller. You may find patient 0, which is the user that got infected, and reimage them. But guess what? You got malware running on your domain controller. So this is kind of a critical thing we're going to need to start doing. LogMD Premium, sysinternals, tool suites, sysmon ID 8 and 10, using WinRM with Arthur, memory dump with volatility are all possible options here. There's many ways to skin a cat. Just pick one or two and try it and get it integrated into your process. So conclusion. Create a process to look for running processes and their modules. Look for signs of injections, more importantly. And test your EDRs, right? Use some of the automated attack tools to test if this condition can be detected. Or actually go, sign up for Skype or Cobalt Strike and try it. Or hire a red team like NCC Group or others to actually use this technique and see if you can detect it. Or afterwards go hunt for it and look for the signs of injection. Log the process command line execution, collect that and alert on that. This is going to be key in seeing its initial execution. And of course, monitor for the executions discussed in this presentation, and you'll be way ahead of the game here. Here's some tools to consider. I've listed a bunch here that are pretty well known, some open source, some freemium items. Some are older projects, may not be as compatible with Windows 10 nowadays. GUR, Recall, Invitero, Memhunter. I couldn't get that to work now that the later versions of Windows and an old .NET version being used. But there's some tools to give you some ideas that you can go play with. Let me know if you have any others as well. Some other homework and resources to look at that definitely will help you understand this area. Again, MIBR attack sub-techniques coming soon, so go read up on that. It's now released. You can go look at the matrix and expand it. The sub-techniques, I really like that. I tell people to go plot that at a 36 by 48, print lots of copies, laminate it, and get your color coders and start highlighting stuff. And if this is a project you take on just for MIBR and map all these process injection and interesting ways of doing things, then great. Make sure you have this covered so that you can catch that example of TrickBot or the other quackbots, Coveters, and Drydex that I discussed in this presentation. And again, some other reading that you can do. So some resources, here's where you get Arthur, here's where you get LogMD, here's where you get the cheat sheets. And with that, we can go ahead and do some questions. I will be hanging out in the my channel down there, so you can ask me all kinds of questions. And with that, we'll start answering some questions.
Excellent. Thank you very much, Michael. I've been keeping track of a lot of these in here. I guess I should first of all say you're probably getting a lot of traffic to your cheat sheets right now because there are a lot of requests for that URL. So we were happy to share that link out. One that came in fairly early on, but I think actually works really well here is if we hibernate a system with some of these processes running, is that findable in the hibernation files? And I was wondering if you could talk a little bit about kind of the post-mortem kind of flavor of memory forensics through something like a hibernation file.
I think in the case of hibernation and extracting that, you're going to have to go traditional forensics. I don't have a good way of doing that outside of doing just typical forensics. So using your typical in-case type tools to be able to take that file and analyze it. There are quite a bit of artifacts in there, right? So you should be able to see the fact that once you hibernated this box, that everything's still there, and there should be great artifacts for you to detect. But again, it's very time consuming. And the idea here is why I said a process is because I think this is something that needs to move more towards the live system analysis, more in the hunting area, more into find a tool that can protect you better here. I know one of a red teamer blurted out, I'm not promoting this particular solution because there's way around all EDRs, but CrowdStrike seems to do a pretty good job in some of these areas. And it really annoys some of our red teamers, right? So the idea here is to look for more detection capabilities, more proactive live system capabilities, because as we go into hibernation, page file, traditional forensics, disk images, they're time consuming. And disks are getting large. They take forever to image. They take forever to consume into the tool that you're using. And so what I'm proposing here is we start looking more at live systems for this area. And so when we get and cross that line into traditional forensics, hyperfill, page file, disk images, at that point, you're going to have to go low and slow and do it the old-fashioned forensics way, is my take.
Yeah, absolutely. Another question that kind of actually follows on nicely to something you were just saying. A question came in about performing some of these types of investigative steps at scale. Wondering if you had any suggestions or pointers on how in a large enterprise you would approach the idea of memory forensics when you've got 50,000, 100,000 endpoints or something along that line.
Well, memory forensics, that scale is why I say let's go do it live, right? It's less intrusive. I remember a little test I did stopping a process on a game environment, each process, stopping it, dumping the memory for each one of those, and then scanning it for signs of the WinNTI strings. And the minute you stop one of the processes that aren't supposed to be stopped and are trying to write data to a database, you'll get a lot of hate email. So you have to be real careful here, right? So in scale, you do have a challenge. You need a tool that lets you go from one to many, whether it's a configuration management tool. So for those who have BigFix, you have probably the best security tool on the face of the planet. Because BigFix not only lets you make a query, like let's say OS Query does, or any question you might want to ponder, you can craft within the BigFix analysis and go out and say, here, go see if I have this. But you also have fixlet capability. And you can push out a fixlet that says, go run memdump and give me an image of this thing, at the proper hour after the backups have done whatever the coordination is. Because remember, at enterprise, you have a challenge. One, you have to fit it in when IT doesn't want to rip your neck off. Two, if you're doing it against a server farm that has shared storage, if you're asking for it to do a lot of disk-related activities, the SANS going to get beat up, and you'll have a lot of IT guys trying to rip your head off. So you have to take these things into account. But a configuration management tool like, let's say, a BigFix would be a great option here, because I can create a job, push out a memdump job to dump the memory to various locations, storage, whatever, that I can then post-process with volatility. Or I can push out a job with, say, lognd or sysinternals or other tools that will allow me to check the running processes on the fly as a typical job that is less intensive on the system. Because you are pretty much looking at only in memory, and of course, again, work with your IT guys to make sure they're not doing some compiling of game code. That would be a bad thing. Again, don't ask me how I know that. So from that perspective, there are tools you have from IT that manage your infrastructure may be of great use to you here. Another one is if you're in a Windows environment, you have Windows RM built into Windows. It's an already existing agent. If you configure that, you have the ability of command line control across the environment, thus projects like Arthur, which are a fork of Conza, as well as the Talkover and Track 2, which I wish was off by an hour so I could watch it. But Jonathan and I have already hooked up, and we're going to have some discussions after the fact. But something that lets you do a one-to-many. And I think Jonathan's on track there, right, is a great example. So definitely watch his recorded talk. This is going to be a Windows RM, Windows specific environment where I can run from my security or several security analyst desktops, push a job across my entire environment, 10,000, 100,000 endpoints as well. I used to work for large healthcare, and WinRM was a solution we used and configured for some of the people that were acquired to investigate them. So good question.
Very cool. And just a slight different kind of perspective on that. My primary focus is on the network-centric, investigations, network forensics, and we use scoping in that same kind of a situation where instead of having a problem that is 100,000 size, we try to figure out like where are the 50, 60, 70 that are in scope, and then we're able to take that scale. Still dealing with 70 memory images is not necessarily feasible in many situations, but exactly. Being able to scope down your problem. Two questions that came in kind of go hand in hand.
To expand upon that a little bit, I would agree. So when we approach threat hunting, we never do it 100% of the time. You don't put a threat hunt tool out there and say, go hunt all the things. For the very purpose of what I said about the servers connected to a SAN, you potentially will crash that environment. And once that happens, trying to get that back is hard. So whenever you address this kind of challenge, definitely do what Phil points out, sampling. Never do more than 10% of the environment at once, ever. Make sure it's refined. Make sure you've talked to everybody. Did anybody see anything? Now, this is going to be more true on servers than it will be on workstations, especially in the case of doing just running process checks. Memory dumps, the user might know something or see something, and if they're compiling game code or any other kind of code where they have a very intensive calculating program running, they will notice that this is occurring. So always do your samples. Go from like 10, then 10 to 20, then 20 to 40, then 40 to 75, and then maybe do the last 25%. But be very leery here of trying to just say, I'm going to go try this and launch everywhere until you are certain there is no impact to running these kinds of tools, because memory dumps across 1,000 or 10,000 or 100,000 units, you'll get a lot of help desk calls and a lot of unhappy campers. So that's a really good point, Phil, that the sampling is crucial here for sure.
We call those the resume generating events sometimes, where it doesn't end well for the person that just YOLOs their admin.
Yeah, RGE as we refer to them as.
So two questions that came in that are somewhat related, so I'm going to try to summarize them both together. Questions came in about doing memory forensics, whether it be at scale or targeted, in cloud environments or in locally virtualized environments. Is there any kind of pointers you've got on how that changes the game at all?
Not really. The process is the same. I won't call it a process, an Andrew Hay-ism with his Canadian twang. The process is the same there, right? You're going to run the same tool suites. It's just this can be ridiculously slow. I've done some VMs and oh my gosh, literally start it and Friday afternoon and come back Monday and it's still not done. So I've been through there. It's time consuming. Understand it's time consuming. Cloud will be a little better, but again, it depends on how big of cloud box you did. But memory dumps, same tool suite. You'll just have to create a jump host potentially within it, and then call that data and save it back and have permissions. So that's pretty much all you have to kind of think about is how do I get to that, like on an open network, and how can I create that jump host or a forensics host within the cloud. Or in the case of the VM, can I create an ESXi box that allows me to see and access all these other boxes so I can do this? But those VMs, those people will notice if you start pounding on them like this. Thus, again, a running process check and looking at their modules is far faster. We're talking a few minutes compared to potentially an hour or more. And not to mention if you have to do an image info to determine what profile you're going to run against this thing. Holy moly, that's going to take up some time.
Yeah, and one that just came in kind of, I guess that's a corollary to what we were just talking about, and I actually don't even know the answer to this, so hopefully you can shed some light on it. How does something like Docker change this? Do you go for the host, or is there some kind of artifact you can use within the container that will allow memory forensics?
Funny, I just recently did a Docker investigation, and you will have to go to the host and run it from the host. Docker is, for the most part, look at it just like ES6i or AWS. It's an instance, right? It manages the instance. Docker in and of itself has artifacts to tell you what kind of traffic is going in and out of those containers. So there is definitely some configuration that needs to occur in Docker. By default, Docker does not log much. So definitely take a look at that. But there's also the concept of Docker has this snapshot viewing capability where you can see the deltas between what was deployed and what was running now, and that potentially can help you as well. But again, it's looking for the changes of the system disk more so than what's running in memory, because the system is usually powered down when you do those comparisons. So yeah, you're still going to have to look at the container running within Docker for the memory dumps and/or running processes. Traffic-wise, you know, you're on what Phil does, right? Look at the traffic of what's coming in and out of the Docker containers.
Right. Very cool. Two related questions. Do you have any? And maybe this is something that you can cover in the cover more extensively in the hallway channel when we're done here. But do you have any recommended resources or things to search for specifically when your examples were all Windows centric? When you get into the Linux or the Mac OS parts of the environments?
So there's utility, as people are aware, the Objective-C utilities has an equivalent running processes utility for Mac OS to use. In the case of Linux, obviously a PS command to see what's running in the process, but more so in Linux, when you're looking for hidden kind of things that attack Linux, look at, because it's so easy to do in Linux, look at what is in /proc, meaning for every process that's running, there's a /proc directory. There's a PID within that, so /proc1, ... 5 ... 10. And then inside that, everything's a file. And inside that is an exe, which points to the thing that's running. And so if they hide all that, they can't hide that you know that the exe is there with this line. And so spit out that line and look for it. And then if you can't see that in PS, then you know that's being hidden. That's a tricky way to go about finding these rootkits. This was how we found the struts vulnerability in the gaming environment, is we ran this check against /proc, found that a couple of /procs were completely hidden. We have no way into it, but we said, well, look past that. Look at the exe and the string that's actually loading the thing that's running, and that's how we found the code that was running on the box. Because it was hidden in PS, it was hidden in /proc, but we know the line that exists that will cause this thing to launch, and that's running. And so that would be my trick there, because it's really easy to hide stuff in Linux from, I mean, this was a 2005 method, so it's been around forever, and it's still being used.
Right. One of the catchphrases that we've got on our memory forensics class, Forensics 526, is, and I always have to take a moment and make sure I don't cross it and screw the logic up, is malware can hide, but it has to run. And that certainly is the entree to memory forensics. So this is the kind of topic that you're interested in. We've got lots of good content around that, both webcasts and certainly Michael, a lot of your resources are helping with that as well. A lot of those free resources we can provide to the community, and you really want to sharpen that knife as best as possible. Forensics 526 is certainly a good option for that as well.